Number 9, which we did, let me revise that once again. So we had to find the smallest number that is multiple of all the numbers from 1 to 10 except for 7. Okay, I guess this question we might not have done. Hold on. We did till question number 8 only. Right, no? Till question number 8 only we have done. Okay, so in the question number 8, what we learned basically that in the diagram given below, Guna has erased all the numbers. She has erased all the numbers except the common multiples. So she has only written the common multiples here, 72, 48, and 24. While the rest numbers from the given circle has been erased here. Okay, now Habib and Nafis. Guys, I'm audible now properly. You guys are not responding. So we have to find out those numbers, that could be and could fill the missing numbers in the empty regions here, right now. So 72 is a common multiple of which two numbers? Think about it. 72 comes in the table of which numbers? Nafis, is my voice reaching you? Habib, what about you?
Yes.
Right. I am audible now. You guys are not responding.
Yes.
You understanding what I am saying here or not? Actively respond in the
Yes.
class.
Sir,
Hmm.
the first one is 7.
7? 72 does not come in the table of 7 now. See,
9.
in
8.
9 8s are 72.
No, sorry, 8.
8. Okay. Okay. But we also need to look at the other numbers also. 48 and 24 also. Right? So we need
For
to look at all
48,
of
it
them.
is 7.
7? 7 sevens are 49.
Oh,
Hmm. Look again. So 72, 48, and 24, these are the common multiples of which two numbers? Which two numbers? Huh? Okay. If you were to talk about the number 3, so all of them are divisible by 3, right? All of them are multiples of 3, isn't it? If it is divisible by a given number, so it is its multiple also. Okay. But are there any other common number also? Think about it. Look again. Let us start doing it in the following manner. Let us write down the factors of 24, factors of 48, and factors of 72. We will write down all of it and then we will find the common factors of all the numbers here. Okay, now? So let us do this quickly. Question number 8. So first of all, let us write down factors of 72. Quickly tell me what are the factors of 72?
72. 1,
Hmm?
2,
2.
9.
What about 3?
Sir, 8 of
3 also. And what about 4?
3. No.
It is divisible by 3, na, Abhi? 7 plus 2, the sum of
Yes.
digit is 9, and 9 is divisible by 3. Okay. 4 also, right? 18 fours are 72. 18 fours are 72. By the way, you guys are able to understand what I'm saying. Like I'm saying a little bit slow. Okay. Like,
Yes, I can understand that.
I still have some problem in my throat. After 4, what about 6? Then 8, then 9. Quick, hurry up. Don't take this much of time.
Then 9, then 72.
12, 6 or 72. Hmm? 12,
Okay.
6 or 72. Okay, next. Is it divisible by 13, by 14, by 15, or by 16, or by 17, or by 18? Huh?
Sir, 12.
12, which I already written. I have already written 12.
18.
18, very good. After 18, you have got
24.
72.
Very good, 24.
Then after that, 36.
Exactly, 36 and then 72.
And then number itself.
Okay, good. Now tell me the factors of 48 quickly.
48. 1,
Hmm?
2,
Hmm?
and
3?
is 3,
Hmm?
4,
4,
then
6,
6,
Hmm?
then
8,
8,
Hmm?
then
12.
12. Yeah, 12.
Hmm?
So
Then
16 will come.
16 threes are 48.
Yes.
yes, then
Next.
24.
Very good. And
Yes.
then
And
Then
48.
then
Very good. You guys are doing good. Next, 24.
34.
24, 24. 1,
Factors of 1,
2,
2,
3,
3,
4.
4, 6,
Hmm?
and 12,
8, 8, 8. Then 12.
8, then 12, then 24.
Very good. Sorry. So these are the factors here. Now let us write down the common factors here. Common factors. So let us first of all circle them. Okay, now 1 is common, 2 is common, 3 is common, 4 is also common, even 6 is common, even 8 is common, right? And then 12 is also common, isn't it? And then you have got 24, right, Nafis? Right, Habib? Where's Sumaya? She's again absent today, no? Okay. You guys have been absent. That's a good. Have been present. That's a good thing. Okay, no, one should not be missing class so often. It creates problem in the exam. Let's write down the common factors. So 1, 2, 3, 4, 6, 8, 12, and 24. I have written all of it. And did I miss any? I have written all, right?
No.
Good.
Yes.
So these are the common factors. All right. Now, here we have to find the multiples of two numbers, right now. And 72, 48, and 24 are going to be the common multiples of those two numbers. Are going to be the common multiples of those two numbers. Okay, let us find it out. Okay, let us find it out. So which number it should be basically. So what we can take, say, let us say, if you were to find out the multiples of 6 and multiples of 8. So multiples of 6 are respectively going to be like 6, 12, then 18, then yeah, after 18 you have got 24 written over here, no? 24, then 30, then 36. After 36 you have got 42. After 42 you have 48 written over here. Getting it now? After 48 we have got 54. Getting it or not? 54, then 60, 66, and after that you have 72 written over here. Getting it, both of you? Yes or no? Now further talking about multiples of 8. So what are the multiples of 8? Yes?
8,
Hmm. 8
8,
ones are 8, then 16,
8 2s are 16,
24 is already
24,
written here. Then
then 30 and
2.
32,
Next,
48.
48.
No,
The-
first 40, then 48.
40 now. Then 48 already written taken here, right? Next.
48. Then
Yeah.
56,
After 48 we have got multiples of 8 now.
56,
8, 8, 8 fours, 8 6 of 48, 8 sevens of 56. Yeah, 56. Then 8 8s
then
are
64.
64, and then 8 9s are 72, right? So here we have written down the all the possible multiples of 6 and 8 here, right now. So we are getting a pair of possible number, right? That is 6 and 8, and we have written their multiples, and their multiples are 72, 48, and 24 also, which are the common multiples here. So a pair of number which could be the possible answer is 6 and 8. But although there are some other possible values also here, see here, we have taken only 6 and 8. But even you could have gone with 2 and 3 also, right? Even 3 and 4, even 4 and 6, even 6 and 8, like which we have taken, even 8 and 12, even 12 and 24. So no matter what, no matter multiples of which number you take here, you will, if every time you will get the number 72, 48, and 24 as common multiple. You getting this point, both of you? In place of 6,
Yes.
I can write 3 and 4 also. That will also be correct. Examiner won't be deducting the marks. Got it now? I could have written 8 and 12 also. Here 8 and here 12. So any one of this could be answer. Okay. If it is clear, tell me. Otherwise, I will explain once again.
Yes, I'm clear.
Good. So it could be either 3 or 4, or either 6 or 8, or either 12 or
Or 24.
24 also. Very good. 12 or 24. Good. Moving on to the question number 9. So find the smallest number that is multiple of all the numbers from 1 to 10 except for 7. Okay, that is multiple of all the numbers from 1 to 10 except for 7. Understood the question? What it's saying? Huh?
No.
Not getting it. See, we have to find the smallest number that is multiple of all the numbers from 1 to 2. Like it is the multiple of 1, 2, 3, 4, 5, 6, 7, 8, not 7, 8, 9, and 10. And it should be multiple of all of them. So here basically what we know, the smallest number that is a multiple of all the numbers from 1 to 10 except for 7 will be the least common multiple of those numbers now. That is what LCM is all about. The number is 1 to 10. So you hereby 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't have to pick the number 7. Do not pick this. So question is asking, find the smallest number that is multiple of all the numbers from 1 to 10 except for 7. So hence our numbers are 1, 2, 3, 4, 5, 6, then 8, then 9 and 10 without 7 here. So all you have to do, you have to find its LCM. You will have to find the LCM because LCM is the lowest common multiple of all the numbers now. So hence find its LCM quickly. 1, 2, 3, 4, 5, 6, 8, 9, and 10. Let's find it out quickly. Okay, so what number should I take first? So that most of them gets divided. We always start by the smallest prime number, right now?
Yes.
Like in most of the cases, we start with 2 or either with 3. So here we should start with 2 now. 1 will be written as it is. In place of 2, I will be writing it 1 here. Then 3, then 2, 5, 2 3s are 6, 2 4s are 8, 9 written as it is, then 2 5s are 10. Got it so far?
Yes.
Okay, next what number should I pick?
Um,
Again?
3.
No, again let's take 2. Okay, so let's write 1, then 3, then 2 1s are 2, then 5, 3, then 2 2s are 4, then 9, then 5. Now let us take 3. Okay, Habib? Tell me, what should I write here then?
3, 1, 1, then 1,
Hmm?
then 2.
2. What about this 1 now?
No, that's actually 2. You wrote it as 1 up there.
Where exactly? No, see, earlier
No,
I
no,
took
no.
2 now.
Okay, I understood.
Hmm. Now
1, and then
5,
5,
then
then 1,
hmm,
then 2,
hmm,
then 3,
hmm,
then 5.
then 5. Okay, now next 5 is repeated 2 times, no? Right? So I can take 5 now. Clear to everyone?
Yes.
So LCM will be the product of all these numbers now. So find out the product of these. We are not going to count 1 for the sake of convenience, because when multiplied by 1, no matter how many times you multiply it by 1, it's going to be same every time. Right, Nafis? So 2 multiplied by 2, then Again, this 2. In total, there are 3 2s now. 1, 2, and 3 over here. There are 2 3s, 3 and 3, and this just 1. Tell me the answer as quick as possible. Whoever answers this question first now, I will give $1 million to them.
Sir, is it 360?
What about you, Habib?
Okay.
Okay. I'm saying, like, what's the answer? It is
360.
360. Very good. So 5 3s are 15, 15 3s are 45, 45 2s are 90, 90 2s are 180, 182s are 360. Like that. Getting it? Very good. So hence the number is 360. Okay. Now question number 10. Sorry. Find the smallest number that is a multiple of all the numbers from 1 to 10. Is it a difficult question? In the previous question, you had to find multiple of all the numbers. You have to find the smallest number that is multiple of all the numbers except for 7. Here you have to include 7. Right now, here you have to include 7. So what will be the answer here? What we need to do here?
LCM.
LCM, exactly. So find out quickly. I'm giving you guys 1 or 2 minutes to solve. 2 minutes to solve it.
Okay.
You know, if you guys just stress out a little bit now, you can just do it very quickly. Why so? Because suppose in this list now, I just look over here, Habib and Nafis. In this, all I have to do is just add 7 here, right? All I need to do is just add 7 here. Getting it now? And 7 is written only once here. It's not 14 or 21 that you need to divide it by 7. Only 7, right? So thereby, how about I simply write 7 over here, and in each of the step, it is going to be written down as it is. In each step, you will simply bring down 7 in each step. You will write it as it is. And at the end, all you have to do is simply multiply it with 7. So 360 will be multiplied by 7. Tell me if this is clear or not. What I'm saying.
Yes.
Nafis, why are you silent in the class? Not getting it?
Sir, I'm getting it. I'm just doing the sum.
Okay. So let's write 7 over here. So in each step, we will simply write it down. The last step also. So simply you have to multiply it by 7. So earlier we got 360 multiplied by 7. There you'll be getting your answer. Quickly tell me the answer.
Sir, is it 2520?
Okay, I will get back to it whether it is correct or wrong. Habib, you also multiplied. Okay, meanwhile, now you open page number, open the next exercise. That should be on page number 114. Okay, from there we are going to continue. Habib, multiply it quickly. Simply multiply 36 with 7 and then put a 0 at the end. Multiply 36 with 7 and then put a 0 at the end. Okay?
Okay.
Yeah. Read the first question, Nafis. Nafis, read the first question.
Can arrange 12 figures in a triangle manner, in a rectangular manner.
Hold
I
on.
got it.
Which question are you reading? This one you have to read, no? I have asked you. Yeah, what's the answer, Habib?
Sir, it, sir,
2520.
111, you
That's
should
correct.
open 112.
112. Hold on.
It's 114.
Let me see which page you're talking about. I don't think I have that. Are there more questions in that exercise? In the page number 111,
No, sir.
are there more questions after 10?
No.
No. Which question were you reading then, Nafis? Give me 1 minute. Let me open that in my phone. Like, hold on. Give me a minute. Prime time chapter, prime time, class 6 PDF. Let me get it in my phone. You're seeing page number 112.
Well, yeah.
112. Okay, that one you're reading. That is not a question now. 5.2 prime numbers. That is not a question. We are doing right now, we are doing the exercise questions. We already have learned about prime numbers and prime factorization and all that. ठीक है Nafis?
Okay, so I have to open page number 114.
Exactly 114. Okay, that page you have to open, both of you. Yeah, so question
We
number 1.
see, okay, we see that 2 is a prime number and also an even number. Is there any other even prime?
What do you guys say? Are there any other
Yes,
even
sir.
prime? Think carefully.
No.
Be very careful. You're saying no. Okay. Nafis, could there be any other even prime number? Is it possible to have for a number to be called as prime number? The first criteria is that it should have only two factors, that is 1 and itself. But if you take another even number, 4 is not a prime number, neither is 8, neither is 10 or any other. Why? Because they have got multiple factors. No? For 4, 1, 2, 4, for 8,
So
1,
the
2,
2
4, 8.
is only a prime number.
Exactly. So hence the answer is no. 2 is the only prime number, only even prime number.
So,
Uh-huh.
so how about 0?
0 is not a prime number, neither a even number. Getting it now? 0 is taken as a whole number. Right now, in whole number, we study about 0. Getting it? It's considered as a whole number. Okay? So that is the thing. 0 is neither positive nor negative, neither odd nor even. Okay? 0 is basically used to represent nothing now. It's used to represent nothing. If you don't have anything, so you basically have got 0. All right? So that is the thing. Moving on to the next question. Look at the list of primes till 100. What is the smallest difference between two successive primes? What is the largest difference? Yeah, so that is some interesting question here. So it is asking you to look at the list of the prime. So in your book, you can get the list of prime numbers from 1 to 100. Look again, let me tell you the page number where you can find it. On page number 113 now, you can look at it. There you can spot it. So all the numbers that have been circled in green, the green circles, they are the prime numbers. Right, Habib? Okay.
Page number?
Page number 114. Sorry, 113. It's not visible here, no? Page number 113. Open that.
None.
There's a
Yes.
bracket like this in which prime numbers have been listed. Basically, all the numbers have been listed, but the prime numbers have been circled in green. So look at that list of prime numbers till 100. So what is the smallest difference between two successive primes? If you turn your camera on. So the first two prime numbers, 2 and 3, right? After 2 and 3, then as per that, then you have got 5 and then 7. And similarly, then you have got 11, then you have got 13, and then you have got 17, and then you have 19, and so on. So if you were to observe it, what is the smallest difference between two successive primes? Successive prime means one after another. Okay, right after a given number is called as successive. So
So
two
2
successive, exactly, no? The smallest difference possible here is 1, that is between 3 and 2. Okay. And also
17
observe,
and
17
Sir,
and 19.
17 and 19.
You have to say the smallest difference between two successive primes. So you have got only one, that is 2 and 3. The smallest difference possible here is smallest. No, it is saying smallest. So that is 2 and 3 only. Now it is saying what is the largest difference. So you guys observe it. See,
89 and 97.
89 and 97. Okay. What about you, Habib?
Yes, same.
89 and 97,
Y-
right?
Yes.
So between 3 and 2, there's a difference of 1, and between 97 and 89, the difference is of 8. Very good. Okay, moving on to the next question. That is question number 3. Read the question, Habib.
Question number 3. Are there an equal number of primes occurring in a very row in the table on the previous page? Which decades have the least number of primes? Which
Hmm.
have the most number of primes?
Okay, so it is asking you to look at the row, this row over here. Okay, now which you just have looked at. So by looking at that row, you have to answer: are there an equal number of primes occurring in every row in the table? Look at the row. Look at each rows here. In the first row, how many prime numbers are there? See, 2, 3, 5, 7,
3,
4,
4, 4,
4. In the next again, 4.
4,
In the third row,
2,
2. Fourth,
2,
2. Third,
3,
3. Fourth, uh-huh.
2.
Third, 2. So are they same? Are they same? Obviously, no. They are not an
No.
equal number of primes occurring in every row in the table. Okay, na? Then further, what was the question asking? What hmm, which decades have the least number of primes and which have the most number of primes? Huh? So observe it once again. The last row has the least number of primes now, right? The last row has got how many prime numbers? Only one now. Getting it? And the first row and the second row have got maximum number of prime numbers. That is 4 in each. Got it? Okay.
Yes.
Now, also here, basically, if you were to read that activity, it was showing that it's basically representing. Hold on. Where's the decade word mentioned here? No. I should have taken that 50 also. Patient that. Anyways. All right. Now moving on to the question number 4. Which of the following numbers are prime? Quite simple. Answer it fast. Out of
Which is
20,
the following numbers of 23,
23 and any more?
37.
37. That's good. Question number 5.
Um, which three pairs of prime numbers less than 20 whose sum is a multiple of 5?
It's not which, but to write. You have to write 3 pairs of prime numbers less than 20 whose sum is a multiple of 5. Okay. Interesting and good question. See. So we are going to write down 3 pairs of prime
I got
numbers.
it.
Okay, tell me.
It's 15,
Hmm?
5,
Hmm?
then
No, that is not the way how you get it. It is asking you to find pair of prime numbers. Pair, you understand? Na? Two prime numbers. Okay, pair, it means simply when two things are in a group, so that is called as pair now. So you have to find 3 pairs, okay, such that the multiple of them is like such that their sum is equal to 5, like the whose sum is a multiple of 5, I mean to say. Okay, now. So first of all, write down all the prime numbers less than 20. So that is 2, 3, 5, 7, 11, 13, 17, and 19, right? So pair number 1, then we have to find pair number 2 and pair number 3. So that has to be less than 20. Okay, 2 is less than 20, 3 is also less than 30, 20. Their sum is a multiple of 5. If I were to suppose take 2 and 3 here. So 2 and 3. Let's say this is the pair I have taken. Now the sum of the pair is 2 plus 3, that is 5. And in the question it is saying that whose sum is a multiple of 5. So 5 is obviously a multiple of 5, right or no? Understood what we need to do? We need to pick those pairs, we need to pick some of the pairs, then we will add them. The value you will get after addition, it should be a multiple of 5. So 2 and 3 is actually one of the suitable pair which we can have. Next, can we have 3 and 5? Can 3 and 5 be taken? Think about it. Keep this
No.
thing in mind. If you take 3 and 5, their sum will be 8. And when you write down the multiples of 8, it's 8, 16, 24, like that. But they are not multiple of 5. No? It should be multiple of 5. Okay, if you got it, try to solve it yourself. Give it a try. You guys give this question a try. Nafis, you're solving it or not? And why do you keep your cameras off in the class? Am I visible to you guys or not? I'm not. The thing you have to keep in mind that you will pick some of the numbers here, like 3 or 5. You can take 5 or 7 or 11 or 13, like that. But you need to also you can take 2 and 13, or you could take 3 or 17, or you could take 11 or 19. But it does not mean that you have to take in a consecutive manner. You can randomly also pick them. But once you find out their sum, so their sum should be multiple of 5. Like their sum should be equal to 5 or 10. Listen to me. I'm saying important stuff. So I'm saying that if their sum is going to be multiple of 5, so their sum must be equal to either 5 or either 10 or 15. So which number's sum is equal to
Sir, is it 2 and 17?
2 and 17?
Yes.
2 plus 17 is 19 now. Huh? So when you write down the multiples of 19, they are 19 ones are 19, 19 twos are 38. Are they multiples of 5?
No.
Nafis, read the question. Read this twice in your mind. Okay, now read this slowly. Habib, you also read the question at least twice. Read this. Look over here and read the question. Do not look here and there.
Sir,
Hmm.
is it 5? Sir, is it 5 and 15?
5 and 15 here. No, see, 15 is not a prime number now. I have to take all the prime numbers that is less than 20. Their sum should be equal to their sum should be a multiple of 5. So I have taken 2 and 3, for example. The sum of 2 and 3 is 5, and which is a multiple of 5. 5 ones are 5, basically, right now. 5. So next number, what I can take? I can take those numbers whose sum is equal to 10. Are
Sir,
there
I
any
got it.
numbers? Tell me.
It's 19 and 11.
It's 19 and 11. Okay. What about you? Indeed, that is correct, by the way. Okay, na? 19 and 11. So let's take that. 19. What happened to this? I need to change this.
No, I guess it is no.
You're saying 11 and 19. What about you, Nafis? It is actually correct now. Why you're saying no? You take
Because it should be less than 20.
no. It is not. Look here. You have to take three pairs of prime numbers that is less than 20. Right? Three pairs of prime numbers that is less than 20. So here it is not saying that their sum should be less than 20. Getting it? That is not what it
Okay,
is saying.
okay.
Basically, in value, it should be less than 20. In value, it should be. So thereby it is great. 11 and 19. Next, their sum is 11 plus 19. That is how much? 30 now?
That's 30.
And it's a multiple of 5. Okay, think of one
5.
more. Hmm. Nafis, in your school, these questions have been done or not? Have
Yes,
you?
sir.
Not yet. Okay, okay. Guys, what about
How about no, no. How about 13 and 2?
well done. 2 and 13. The important
Sir,
thing is that they're
13 and 17.
13 and 17. Yeah, we can take that also. Very good. So 2 plus 13 is equal to 15. Yeah, it is correct. It should be a multiple of 5. So there it is. You can take some pair number 4 also, 17 plus 13. So the sum is 30. Hence that is also correct here. Okay, you guys are doing good. Question number 6. One of you please read this. Habib, you read this.
The numbers 13 and 31 are prime numbers. Both these numbers have same digits 1 and 3. Find such pairs of prime numbers up to 100.
Getting it. So we need to find such pair of prime numbers whose digits are basically same, right? Whose digits are same, no matter like if they are reversed, written in the reverse manner. I will give one example to you guys. Other than this, what happens to this? What about 13 and 31? Huh? It's the same type of pair of the prime number, isn't it? 13 and 31, they have the same digit 1 and 3. Sorry, what's there in the question? About after 13 and 31, what about 17 and 71? Right?
Sir, we
Yes
only
or no?
have to take prime numbers.
Yeah, we only have to take the prime numbers as mentioned in the questions. The digits should be same. Think of it quickly.
Like the first digit should be same.
No, that is not the thing. The digit should be same. It's not the, basically in 13 and 31. What are the digits? 13 has 1 and 3. 31 also has 1 and 3. I give another example of 17 and 71. 17's digit in 17 is 1 and 7. Digits in 71 is also 1 and 7. I'm not saying you about
Okay,
the ordering, like which
understood,
digit is
understood.
written first.
Sir, 37 and 73.
Very good. Well done. Well done. Good. And
Uh,
13 and
sir, can we
31 you have.
take 31 and 13 and 31?
It's already
Oh,
in
we
the question.
already
Now.
took it.
You also gave one more 37 and 73.
Oh, is sir 17 and 71? Oh, yeah, it's the.
Already written here, no?
Sir, 97 and 79.
Very good. 97 and 79. Okay. So these are all the pairs of prime numbers of the like they that consists the same digits in them. Well done. That's it. There aren't any other pairs than these four. Okay, now. Okay. Question number 7. Find 7 consecutive composite numbers between 1 and 100. So you guys already know that what are composite numbers now, right? The numbers that have got multiple factors. Okay. But the thing is that they should be consecutive. They shouldn't be sorry. They should be consecutive, one after another. So think about it. For question number 7, let me tell you one example. Question is asking you need to find the consecutive composite numbers. Consecutive numbers are what? Like you have got the numbers like 6. Huh? After 6, you have got 8.
8.
You have 9, 10. Then you have 12. Then you have got 14, 15, and so on. But are these consecutive? Are these consecutive numbers? Consecutive composite numbers? They are not. No, consecutive means that the difference between the two number is only one and not more than one. But here the difference of these, somewhere it is 1, somewhere it is 2, somewhere it is 3, right? Not everyone it is same. So here the difference is 2, here it is 1, here it is 1, here it is again 2. So consecutive number basically means that it should be in a series. Getting the point I'm trying to make here?
Yes, sir.
Okay, so think of some. Yes. Let's say if you were to start from 20, 20, 21, 22, but now you're getting 23. That's the problem, no? There should be 7 consecutive composite numbers. A prime number should not come in between. Let's move to another. 30, 31. Right after 30, 31 came, which is a prime number. That's not possible. Okay, 40, 41. Right after 40, a prime number came. Getting the point I'm making here? After 50, we have 51. Okay, 51 is a composite number. Let's continue. 52, 53. Sorry, 53. There we have the problem. Right after 3 consecutive composite numbers, we have a prime number. In the question, it has been mentioned that you need to find 7 consecutive composite numbers between 1 and 100. So it should be one after another in continuation. So let's say 60, 61. Right after 60, I have got 61, which is a yes,
Prime number.
prime number. But I should not get a prime number right now. Okay, 70. Then I got 71. 71 is a prime number. So it's not suitable. 80, 81. Okay. 82. Okay. 83. There we have the problem. 83 is a prime number.
Sir, 90 to 96.
Exactly. There you go. There we have our answer. 90, composite number. 91 also. 92, 93, 94, 95, and 96. So 1, 2, 3, 4, 5, 6, 7. Got this now, both of you? Here we have
Yes, sir.
7 consecutive composite numbers. Hope it makes sense to both of you. Any questions?
Yes.
Habib seems a little bit confused to me.
I didn't understand.
Okay. Okay. Listen attentively once again. In the question, it is saying that consecutive, you understand now what consecutive means?
Yes, yes.
What does it mean?
It means like what do I say?
Okay, you can speak that in Urdu also. If sometimes you find it difficult to explain, you can explain that in Urdu also. Okay, like Urdu
I
is,
know composite, not consecutive.
yeah, it's
I know
consecutive.
composite.
Okay, that's what the thing. That's the thing, no? You should have asked me that what consecutive means, no? See, consecutive means in continuation without a break. In continuation without a break. Getting it?
Yes.
In continuation without a breaks. Like suppose you
Okay,
are
understood.
taking the steps. So you are taking one step at a time, not taking 2 steps, not taking 3 steps like that. So we need to find consecutive composite numbers. So there we started from 1. Okay, but 1 is not prime number, obviously. So like from 1 to 10, we had the composite numbers respectively. They were 6, 8, 9, like that. Then 10, then 12, then 14, then 15. Getting it? But the thing is that these are not consecutive composite numbers, no? Because consecutive prime numbers would be like consecutive composite numbers would be like this, no? 90, 91, 92, 93, 94, 95, 96, and we had to find only 7. So here we have our answer. Okay, you guys do the question number 8. Let me get some warm water. I'm having difficulty in my throat. Okay, I'll be back in a minute. Meanwhile, you do the question number 8.
Sir, finished.
Yeah, I'm back. Finished? Okay. So what did you got the answer? What's the answer?
Sir, the answer for eighth one is 11 and 13, 41 and 43, 59 and 61, 71 and 73, and 29 and 31.
Very good. Did you mention 17 and 19 also?
No, because in the question it's already mentioned.
It's mentioned, no? Okay, very good. So 3 and 5, 17 and 19. Then you have got 11 and 13 also, which you mentioned, 29 and 31. Very good. Right, so twin
Yes.
primes, we know that they are the prime numbers that are having a difference of 2 in them. So hence these are the answers. Very good. Well done. Habib, you also got it, no? Right? Yeah, Habib?
Yes, I got it.
Okay, very good. Okay, now we move on to question number 9. All right. So we have to identify which statement is true or false. So there is no prime number whose unit digit is 4. Is it true?
Sir, true.
Indeed, it is true. Right now, that's true. Because if a given number has 4 in its unit digit, obviously it is not prime number. It's going to be composite number, right now. Okay,
Yes.
moving on to next question. A product of primes can also be prime. Is that correct?
False.
If that is false.
False.
Right now. So it is saying that a product of primes can also be primes. Okay. Let us take some example here to understand this, whether it is actually true or whether it is actually false. Suppose we have the number 2 and 3, right now, 2 and 3. So 2 and 3, both of them are prime numbers, but their product is 6 now, right? Hence the given statement becomes false. Okay, so that is the thing. Next, prime numbers do not have any factors. Is that correct, Habib? Yeah, Nafis?
Yes.
They do not have any factor.
False, sir.
They have only 2 factor, no? Do not hurry while answering.
So,
This
sir, it
statement
is
is false.
false.
It is
It's
false.
true.
Prime numbers do not have any factors. How is it so? How is it
No,
true?
it's false. False. Sorry.
No worries. Okay. Also, you can never say sorry in the class. Okay, na? Why so? Because when you say like, basically, there's no sense in saying sorry. I find it stupid to say sorry if you're not getting the answer. Okay, na? All even numbers are composite numbers. Is that true?
False.
Why so? Because we have one even number which is a prime number. Right now, that is 2 now.
Yes.
So 2, 4, 6, 8, 10, right? So all of them are not composite numbers. Why? Because 2 is an exception. It's a prime number. Good. 2 is a prime, and so is the next number 3. For every other prime, the next number is composite. For every other prime number, the next number is composite. Is that true here?
No, sir, it's false.
It is
No.
false, you're
False.
saying. Okay, see, for example, 2 is a prime number followed by a prime number followed by a prime number 3. Let us take some other examples also. Let me erase all of this first. 2, then after that we have got 3. Let's say we have got the number 5, which is a prime number. After 5 we're having 6, which is a composite number. Right? Let's take another prime number like 7, right? After that you have got 9. 11, after that you have got 12. 13, after that we have got 14. So what can we say about these numbers? Yes or no? Is this statement true now?
Yes.
Right? Getting it, Habib?
Yes.
Okay, no? So that is the thing. Okay, no? Okay, so hence it is true actually. Next, which of the following number is the product of exactly 3 distinct